We think planets are big. Our planet feels huge because we live on it. Then we look at the sun, and suddenly Earth becomes a tiny dot. Then we see stars much bigger than the sun, stars so large they could swallow entire solar systems. Then come galaxies, hundreds of billions of stars, spinning in silence. Then black holes, objects so dense that even light can't escape. We call them monsters. We think this is the end of the scale. But here's the problem. None of these are the largest things in the universe. Not planets, not stars, not galaxies, not even black holes. There are structures so vast that light has not crossed them since the universe was young, and once you see them, everything you thought was big will feel small. To understand what comes next, your mind needs a reset. So let's move fast. The solar system. 8 planets, billions of kilometers, already too big to imagine. Now pull back. The sun becomes a grain of dust. The entire solar system collapses into a speck. This speck lives inside the Milky Way, a galaxy so wide that light takes 100,000 years to cross it. 100,000 years. And yet, the Milky Way is not alone. It's part of something called the local group, dozens of galaxies, drifting together, pulled by gravity like leaves in slow motion. But even this is not the full picture. The local group is just a neighborhood. And neighborhoods form cities. Cities form continents. On the largest scales, the universe stops feeling like space and starts feeling like structure, something arranged, something vast, something your intuition was never built to handle. And this is where things begin to break, because at the next scale, individual galaxies no longer matter. They become background noise. And what replaces them is far bigger than anything you've imagined so far. At this scale, space changes behavior. Galaxies stop acting like lonely islands. They gather hundreds, sometimes thousands of galaxies bound together. Not touching, not colliding, but trapped, locked by gravity into enormous families called galaxy clusters. Inside a single cluster, galaxies orbit a common center, moving at millions of kilometers per hour. Yet here's the strange part. The galaxies are not what holds the cluster together. Most of the mass is invisible. An unseen substance creating gravity without light, dark matter. It outweighs everything you can see. Stars become decoration. Planets become irrelevant. Even black holes lose their importance. At this scale, they are just details. Tiny knots inside much larger systems. Zoom out, and a cluster looks solid. Zoom in, and it's almost empty. Vast distances, endless darkness. And still, this is not the largest structure. Galaxy clusters themselves are not alone. They gather too, they align, they connect. And when they do, they reveal something no one expects. Because the universe does not organize itself into blobs. It stretches, it threads, and what comes next is not a cluster. It's the skeleton of everything. When we zoom out far enough, the universe reveals its true shape. Not chaos, not randomness, structure, vast strands stretching across unimaginable distances. These are cosmic filaments, enormous rivers of matter, made mostly of dark matter, invisible but powerful. They connect galaxy clusters like threads in a web. Along these filaments, galaxies are not evenly spread. They cling. They line up like droplets on invisible wires. From far away, clusters look like bright nodes. Filaments look like faint bridges between them. Together, they form something unsettling. A cosmic web. The universe is not scattered. It is woven. Every large structure we see is guided by this network. Galaxies flow along these filaments. Matter streams through them for billions of years. Even light follows paths shaped by their gravity. At this scale, there is no center, no edge, just threads crossing the observable universe. And once you notice this pattern, you can't unsee it. Because between these threads, there is something just as important. Something even more disturbing. Not structure, not matter, but absence. And it is far larger than the filaments themselves. Between the filaments, something feels wrong. Not darkness, not distance, but emptiness. Vast regions where almost nothing exists. These are cosmic voids. Enormous bubbles of space. So large that entire galaxy clusters could fit inside them and still feel lost. In these regions, galaxies are rare, sometimes separated by hundreds of millions of light years. Gravity here is weak. Matter has been pulled away toward the filaments, leaving behind something unsettling. Nothing, but this nothing is not small. Some voids stretch wider than anything the human mind was built to picture. They are not gaps. They are structures, shaped by what is missing. At this scale, emptiness becomes a feature of the universe, a defining one. The universe is not mostly made of stars, or galaxies, or even filaments. It is mostly made of absence, silence, expansion. And when you realize how much of reality is empty, something shifts. Because if nothing can be this enormous, then what comes next breaks every remaining sense of scale. Because there are structures, not made of threads, not made of voids, but made of both, stitched together into shapes so large, they begin to challenge the universe itself. At some point, the scale stops making sense. Filaments connect clusters, clusters border voids. And then we notice something else. Walls. Colossal formations where filaments and clusters merge into continuous structures. Not hundreds, not thousands, but tens of thousands of galaxies linked together, stretching across billions of light years. One of them is called the Sloan Great Wall. It is so large that early maps of the universe didn't even know how to classify it. Then there is something even more extreme, a structure so vast it sounds fictional. Hercules-Corona Borealis, so large there's enough time to cross it since the universe began. Not because light is slow, but because the structure is that big. At this scale, the universe starts to feel uncomfortable. These walls are bigger than what our models expected. Bigger than what should exist if the universe were evenly spread. They shouldn't be here, and yet they are. Spanning a significant fraction of the observable universe. When you look at them, something breaks, not just your sense of size, but your trust. Because the universe was supposed to smooth out at large scales, uniform, predictable, balanced. These structures suggest something else, that on the largest scales, the universe may not be playing by the rules we thought it followed. And this leads to a problem, not a small one, a fundamental one, because if these walls are real, then something about our understanding of the universe is incomplete. And that problem sits at the edge of modern cosmology. For decades, cosmology rested on a simple idea. On the largest scales, the universe should look the same everywhere. Smooth, even balanced. No special places, no giant patterns. This idea is called the Cosmological Principle, and almost everything we know depends on it. Our equations, our simulations, our predictions, they all assume that if you zoom out far enough, all structure disappears. But the Great Walls refuse to disappear. They remain visible at scales where nothing should stand out. Too large, too connected, too coherent. According to our models, structures like this should not have had enough time to form. Gravity should not be able to organize matter this efficiently. Not in the age of the universe. Not across such vast distances. So scientists are left with uncomfortable options. Either these structures are rare statistical flukes, or our measurements are incomplete, or something about the universe's early behavior is missing from our understanding. None of these answers are satisfying, because every new map makes the problem harder to ignore. The universe is supposed to become simple when viewed from far away. Instead, it becomes strange, patterned, almost intentional, and that forces a final realization. Not about equations, not about models, but about us. Because if the universe itself does not fully obey our expectations, then our place inside it is far smaller than we ever imagined. And that realization leads to the final thought. One that has nothing to do with science and everything to do with perspective. When you step back far enough, something becomes clear. The universe is not built around anything familiar, not stars, not galaxies, not life. Structure exists on scales so large that meaning starts to dissolve. What we call massive is just texture. What we call empty dominates everything. We are not standing in a grand design. We are drifting inside a system too large to notice us. Our entire galaxy is a flicker on a filament. That filament is a thread in a wall. That wall is a wrinkle in something far bigger. There is no center pointing at us. No edge waiting for us. Just expansion. Patterns without purpose. Scale without comfort. And yet, here we are. Tiny observers trying to describe something that does not care if it's understood. The universe doesn't need us to exist. We need the universe to ignore us long enough to survive. Black holes feel terrifying. Galaxies feel enormous, but they are not the true giants. The real dominators of the universe are silent, vast, indifferent. And once you see the largest structures, you realize something unsettling. The universe is not built around us. We are simply drifting inside it. But attention, this perspective only holds if you avoid the fatal mistake most people make when thinking about cosmic scale. And that mistake changes everything. I explain it in the video on the screen right now.